ma'am to deliver the welcome address.
Good morning, one and all. I feel privileged to extend my warm welcome to all presented here. Thank you for taking time out and being here today. On behalf of Rajapalayam, Rajus College, Rajapalayam, Department of Mathematics, CSF, and on behalf of our management, principal, and all faculty members, we are cordially welcome you the online webinar on studies on fuzzy topological space. It's a pleasure for me to introduce our speaker, Dr. Lakshmana Gomathi Nayan, sir, Associate Professor and Head, National Institute of Technology, Tirupalli. He has 20 years experience in teaching field. He expertise in fuzzy topological structure, fuzzy algebraic, and fuzzy clustering techniques. His academic identities are Orchid Scopus, researcher, and Google Scholar. He published 38 articles in journals and he completed 6 research projects. Under his guidance, 5 scholars are awarded PhD. He honored 3 awards, 2 from NIT and 1 from CSIR. He is a member of Taiwan Fuzzy Association, Indian Mathematical Society, and Indian Society for Technical Education. It's an honor and privilege for us, sir, to have you with us today. Once again, I welcome you, sir. Now the time is yours, sir. Please start your presentation, sir.
Okay. Shall I, madam?
Yes, sir. Yes, sir.
Yeah. So, first of all, I thank the organizers who involved in this particular seminar through web. Okay, so it is called webinar, right? I thank everyone for attending this particular webinar. Okay, and then I start my talk. Okay, so the talk is titled with studies on fuzzy topological spaces. I started my research on fuzzy topology, right, in the year of 2097, and I awarded a PhD on this particular title in 2002. Okay, then I guided some students on fuzzy topology and all, and now I am working on the other application domains and all. Okay, so after a long time, okay, again I have come with my own title, okay, fuzzy topology. With this introduction, I come to the roadmap of this particular talk. Okay, the roadmap of the talk is nothing but the introduction of the fuzzy logic. Then fuzzy set theoretic preliminaries and all we have to discuss. Then what do you mean by fuzzy topological space? That I will. Then the separation axioms in fuzzy topological space. That is the main topic of this entire talk. Okay, and some of the things available in fuzzy filters also I am trying to tell. Okay, and one more induced topology. Right, based on the time permits. Okay, I will do all the things. Otherwise, okay, with your permission, I will stop somewhere depending on the time. Okay, so I start with the introduction, right? So when you start about the introduction of the fuzzy logic, okay, so then you have to think about before fuzzy logic what it was. Of course, everyone we know, right? It is a binary logic, right? So binary logic was invented in the year before Christ 300 by Aristotle, right? So to study the propositions which are well-defined statements with truth values either 0 or 1. That means it is well-defined. Not only well-defined, it is the truth value is it is completely true or completely false. That type of logic only it was before fuzzy logic. Okay, so by Aristotle in BC 300, right? You see, assume 300 BC, right? Then after that, so the mathematical structure of the further generalized logic is in 1930 by Lucas by giving a multi-value logic. Okay, so in the binary logic, that set of truth value is only 2, 0, and 1. Right? In many scenario in the real life can't be studied by the binary logic. Right? So many examples you can have. Right? So usually I try to tell with the statement of I am liar. right? So if I would tell I am liar, then the statement neither it is true nor false, right? Because once you start with 1, then automatically it is ended up with 0. Similarly, once you start with 0, then it is ended up with 1, right? So that you can just think over, right? So I am liar, it is a statement. If the truth value is 1, then the statement is true, right? So that means I am liar. That is the truthness, right? So what I have told is also lie. I have told I am a liar. That is lie. That means I am not a liar, right? Therefore, once you start with 1, then it is ended up with 0. Similar argument holds good for 0 to end up with 1, right? Therefore, that type of statements are available in the real life. Okay, so that cannot be studied by binary logic. That was the starting point for the higher generalization of the binary logic. Okay, so you see, 1930, after 2,200 years, a mathematical structure for the generalization of the binary logic was invented, right, by Lucas. That is why it is called Lucas logic or multibody logic. Right? There you can have n state of truth values from 0 to 1, right, which includes 0 and 1. And in between also you can have, suppose I want to define 3-value logic, then the state of truth values are 0, 1 by 2, 1. Okay, 0, 1 by 2, 1. Then suppose I want to develop with 4-value logic, that is also possible, right? The endpoints are 0 and 1. In between, right, I want all equal, therefore I can think over 3. But in general, n, suppose I want to develop, then 0, 1 by n minus 1, 2 by n minus 1, and n minus 1 by n minus 1 you take it, then that gives n state of truthness, which includes 0 and 1. Okay, so that is the model or the structure for multivariate logic. Okay, now you assume multivariate logic is there, right? But whether it is enough for studying all the real life scenario, right? Then it is not enough. So then again you have to think over example. The example is, okay, the predicate form of the close to 0. Right? Suppose you take in universe of discourse R, right? Suppose I want to tell x is close to 0, then any real number is close to 0, Therefore, for each real number, I want some state of truthness. So uncountable real numbers are there. Therefore, it is required to have some other generalization than the multivariate logic. Right? So that is again the starting point for Lodvier-Zade. So for his electrical engineering problem, right? So this fuzzy logic itself, it was invented by a person who is an engineer applied in the real life application, right? That is why this fuzzy logic has got a reputation, and it was widely accepted and studied by many mathematicians and applied engineers. Okay, that is the introduction behind the fuzzy logic, right? Now, if you accept this fuzzy logic, then based on which, so I can study the proposition, right, well defined in English, right? At the same time, the truthness is between close in 0, 1 to 0 to 1, right? Therefore, the entire interval can be taken for the state of truth values, right? So this function is called the truth function, right? So wherever you go, so truth function or binary logic or set theory or function, so they are all traveling in one another, right? Therefore, one is corresponding to the other, right? One correspondence we have. Similar, that is why we studied all functions, set theory, and logic and all in one discrete structures, right? So the same way here also. So once you have fuzzy logic, right? Fuzzy logic is nothing but the study of statements in which the truthness between 0 to 1, right? Therefore, so it is a function again. The function, it maps each sentence to 0, 1, So that can be resembled in the set theoretic form by taking any universe of discourse, right? If you take universe of discourse capital X, then for each X, I can think over some function from X to 0, 1, right? So that resembles its characteristic function, right? So the characteristic function is what in crisp theory, in subset theory. So suppose I develop chi A, right? Chi A of, let capital X be a universe of discourse, and capital A is subset of capital X. Then chi A is nothing but it is a function from X to two values 0 and 1, right? With chi A of Z equal to 1 if Z belongs to capital A or 0 otherwise. Okay. Therefore, it is nothing but it is a function from X to two values 0, 1. right? It is imitating the characteristic function. The same thing you generalize in the fuzzy logic by fuzzy set with the membership function, right? So the membership function now, it is nothing but it is the function from capital X, the universe of discourse, to close interval 0, 1, right? So this is called function. It is nothing but it describes subset. Okay. So fuzzy logic and fuzzy subset, they are not two different entity. So both are similar to one another. Okay, fine. A fuzzy subset definition. What do you mean with fuzzy subset? In any universe function defined from x to close to 0, 1, then we call this function as a fuzzy subset of x. Okay, because it generalizes the characteristic function. That is why. So we call it is fuzzy subset. Okay. Now, this is the definition it was given by Lord Zade, right? So, according to him, so the fuzzy subset means in any universe of discourse, right? So, it should be non-empty, right? Then there is no meaning of mapping, Therefore, it is taken as the non-empty set, and the I is nothing but a close interval 0, 1, the state of truthness, right? Then a map from x to I, it is called fuzzy subset of x. It is nothing but is the membership function, right? So any fuzzy subset, it is fully characterized by the membership function. That is the idea, right? So now, if you understood the particular concept of fuzzy set, then obviously the remaining things you can think of that, right? So fuzzy subset is defined. Then in CRISP theory or in set theory, so once you develop the set or subset, then automatically we study the complement, the equality of sets, and different forms of intersection, union, and further generalization down, right? So we will see one by one, okay? So some of the things are very much important for studying our fuzzy topological spaces, right? So because any topology, when we think over, then it is all involved with the subsets of X along with the three axioms in which intersection, union, and complements are playing a lot, okay? Therefore, in fuzzy set theory also, how they are developed, okay? So that is important, right? Now you take two fuzzy subsets, right? Two fuzzy subsets means what? So they are all function from x to close interval 0, 1, right? Therefore, mu is a function from x to 0, 1, and u is a function from x to 0, 1, right? Now, these two fuzzy subsets, when I can tell, okay, mu subset of nu, right? So mu subset of nu, right? In function analysis, we have, right? So to function f and g are given, then f less than or equal to g, the meaning is f of x less than or equal to g of x. Right? By taking that concept, this development is done. Right? Therefore, mu subset of nu is given if mu of x less than or equal to mu of x for every x belonging to x. Right? So people, they usually tell, okay, so mu and nu, they are functions, Therefore, it is a study of functions only. Yes, of course, it is a study of functions. Right? In functions, we have different class of functions. Right? So the study of continuous functions, right? So similarly, the study of probability functions, right? Similarly, this type of functions is a study of membership functions or study of fuzzy subsets. Okay, right. Now, so when I have mu subset of nu, then mu of x less than or equal to mu of x for every x belongs to capital X, because the functions are developed on capital X. Okay, right. Then two fuzzy subset mu and nu, they are equal, right? If mu of x equal to mu of x for every x. Okay, so this is again a further base, right? Now, once you have the fuzzification or fuzzy sets, from the fuzzy sets, can I go to the ordinary subsets, right? So that is a question, Right? Of course, it is possible. So by taking alpha cuts, right? So this definition is given for alpha cuts, right? For you take alpha belongs to close to 0, 1, then the mu alpha is collecting the members of x for which the membership grades are greater than or equal to alpha, right? The mu of x, it is called membership grade, right? Mu is membership function and mu of x is membership grade, right? So therefore, the collection of all x in capital X for which the grade, membership grade is greater than or equal to alpha, right? So of course, this is called alpha level subset or alpha cut. Okay, so this is one of the differentiation technique, right? It is usually we use in our classroom scenario. Right? So we give grading from 0 to 100, and we finally make the ordinary subsets who are all pass, right? By giving some 50 cut or 40 cut or 35 cut, okay, depending on the degree and importance. Okay. Similarly, so from the fuzzy subset, I can go to the ordinary subset by taking alpha cuts. That is the definition here. Okay, right. Then the next one is alpha lower level, right? Here it is greater than or equal to alpha, Then instead of greater than or equal to alpha, if you think over less than or equal to alpha, then it is alpha lower level subset. Okay, this also gives again defuzzification from the fuzzy subset to the ordinary set. Okay, fine. Right. Now I come to the next one. This is also again the defuzzification technique. It is called support of U. Right? It collects the members of X for which the Gödel value is positive. Right? So of course it is a function from close X to close interval 0, 1. You know. Therefore the range may be okay. It is close interval 0 to the other values. Right? If you have the 0 in the range, then those X you just omit. The remaining X only you have to take it. That's the meaning. Right? So collection of all X in X, mu of X greater than 0. Right? The similar definition is available in functional analysis also. Right? From there only it is got up here also. Right? Here it is only the function has codomain only close interval 0, 1. Therefore, it is required to or it is enough to take greater than 0. Right? So not equal to 0, it is nothing but it is greater than 0. That is why the support of A you can define this way. Right? So now support is also there. Okay. Then why these are all required? When we go for modeling, I want. Okay, so but in our talk we are not going to use much more these alpha cuts and support and all. Right? When you think over the imitation of the number theory, then fuzzy number is required. You know that the alpha cut supports and all it is used. Right? But I stick on here and I am moving towards the fuzzy topological space. Therefore, it is not that much of important for us. Okay, but anyway, it is a set theoretic preliminary. So for it's a common domain, you know. So many people they may be knowing fuzzy logic. Some people they may not be knowing. That is why some preliminary is also given here. Okay, right. Now, so I have so some defuzzification. Then the question is right: can I model or generalize a point? Okay, that is the question. Right? In the set theory, we have singletons. Can I imitate the singleton by a fuzzy point? Right? So it is possible. So that definition is here given. Right? A fuzzy point P, right? It is nothing but it is a function from X to 0, 1. It is a fuzzy subset. It is given, you know. Therefore, it is a function from X to 0, 1. But it has singleton support. That means what? At X only non-zero value membership grade is given. At all other places it is only 0. Right? That is the meaning here. Singleton support means what? It is the collection or subcollection of capital X for which the greater than 0 is at only singleton X. Right? Therefore, the non-zero grade is possible only for X and at all other places it is 0. Right? So that means it imitates, try to imitate the singleton. Right? So in the singleton, usually in ordinary singleton, how we will do think over it is nothing but corrective function on singleton, you know. Therefore, at X the value 1, at all other places it is 0. Right? Now the 1 is somewhat fuzzified by taking open 0 to open 1. That's all. Right? The P of X it is support singleton. At the same time, the membership grade it is taken from open 0 to 1. It is not even included 1. Okay, so that is important here. Okay, right. Now, so this will give some theorems and studies and all. Right. Now, once you develop the fuzzy point, right, it is nothing but the generalization of the point. Then, when it is contained in the set, so that is the next question, you know. Right? So usually we do the same. So X is a point of capital X. Then obviously we think over whether X belongs to A. Right? Then what do you mean by belongingness? The membership grade equal to 1, then we call it is belongingness in ordinary set. But in fuzzy subset, the membership grade, okay, so it may be different depending on the mu, right? Therefore, so the development is now, what is the meaning of containment in the fuzzy subset? That is the thing it is given. At XP and unempty set, a fuzzy point P will support X is said to lie in mu. Mu is a fuzzy subset. It is a function from X to 0, 1. The notation is P belongs to mu. If P of X strictly less than mu of X, right? So this is the definition it is given by Jnana, right? Fuzzy point. Strictly less than mu of X. Okay. Now you have this definition. Then obviously we are checking some theorems and all, right? So based on which the system is developed. Okay, fine. Now one more development or one more generalization, it is called fuzzy singleton. So what is the difference between fuzzy point and fuzzy singleton? You know, fuzzy point, it does not include the Gödel value 1 here, but here you see in fuzzy singleton, the Gödel value 1 is also included. Right? So again, the definition remains fuzzy singleton P of X is some fuzzy subset of X, which has singleton supports singleton X, and fuzzy value here belongs to open 0 to close to 1. Why it is so in the earlier scenario in the fuzzy point 1 is not included, therefore it cannot be the generalization of the Singleton, right? So Singleton cannot be viewed as fuzzy point, because in Singleton, obviously the Gretel value is 1. But here it is omitted, Therefore, that Singleton is not a fuzzy point. But when we apply in many systems and studies, we want to generalize the concept of Singleton as it is. Therefore, it is required to include that 1 also. Right? So that is the way of developing fuzzy Singleton. Okay, fine. Now, when the fuzzy Singleton belongs to mu, right? For this question, P of x less than or equal to mu of x. Okay. P of x less than or equal to mu of x at one point is enough, right? But usually the people they write P of z less than or equal to mu of z. It is true because P is having only support at x only. Mu of x has codomain 0, 1. Therefore, at all other points it is verified because at all other points it is 0 only. Therefore, it is verified. Right? Therefore, at one point where the support is non-zero, that is enough to verify with P of x less than or equal to mu of x. Okay, fine. Now, the union of sets, fuzzy subsets, and intersection of fuzzy subsets, they are defined like this. Okay. Suppose you take mu alpha, it is a collection of fuzzy subsets. Then the union is nothing but up mu alpha, right? Which is nothing but supremum mu alpha. Right? And intersection is given by cap mu alpha, that is nothing but infimum mu alpha. Right? How these are generalized, then it is depending on the conjunction and disjunction available in the binary logic. Okay, the conjunction is nothing but our intersection, and disjunction is nothing but our union. Right? Therefore, so how they have been developed in the crystal logic, based on which the truth table you have to take it. The same truth table here you have to generalize in the concept of union and intersection. Is it okay? So in the arbitrary union, we have supremum, and in the arbitrary intersection, we have infimum. But if you have only finite subsets, then that will give only supremum is given by only maximum, and infimum is given by minimum. Okay, so that is the way of development, the union and intersection. Right. So once you have union and intersection, then obviously you can think over the complement also. Right. So the complement, what would be the complement? Complement of x equal to 1 minus mu of x, x belonging to capital X. Right. So this is the complement of the first subset. Right. Now I have union, intersection, and complement. Then that is the main tool for developing our topology. Right. Therefore, I can study now the topological spaces and all. Right. So here one more important note is given. So in the fuzzy singleton, right, when you start with the fuzzy singleton, then there is P belonging to mu I. Right, for some I, that implies P belongs to cup mu I, right? But the converse is not usually true, right? So you see, so the fuzzy singleton, so P belongs to mu I means what? P of x is less than or equal to mu of x. Then obviously less than or equal to the supremum also. Therefore, P belongs to mu I in any one I, that implies P belongs to cup mu I, right? But the converse is not true. P belongs to cup mu I need not imply P belongs to mu I for some I, because here less than or equal to is included according to fuzzy singleton, right? So therefore, if you include equality, I can find 1 minus 1 by n like that, then supremum is 1, but no, a point may be lying in the union, but not in the individual, right? 1 minus 1 by n, right? Therefore, this converse need not be true, but this converse is also true in fuzzy point. Because when you take fuzzy point, the belongingness is defined by only strictly less than. Okay, that is the main discussion behind this particular note. Okay, then you can think over by your own this proof and all. Right. So I have union, intersection, and complement. Okay, then based on which I can develop topology. But I am interested in the separation axioms. Therefore, in the separation axioms, I wanted to think over the disjointness. Right. Because any Hausdorffness or any regularity and all, so it is all dealing with the disjoint separation for 2 point or a point with the closed set like that. Therefore, what do you mean by disjointness in the fuzzy subset? Right. So usually we can think over intersection is empty. Right? A and B are said to be disjoint if A intersection B equal to empty. Right? So based on which one development it can be done, because intersection is nothing but the cap or minimum. The minimum, if it is equal to 0, then I call this mu and B are disjoint. This is one way of development. The another one is also there, mu less than or equal to mu complement. Okay, so this is also definition for disjointness. At the same time, one implies the other does not implies to the 1, right? That means the converse need not be true, right? So this disjointness, right? Mu and nu, if the intersection is equal to empty, then obviously this mu less than or equal to nu complement, right? But the converse need not be true. For example, if you take mu equal to 0.5, the constant Fuzzy subset, then nu also you can take the 0.5, right? Therefore, nu complement is again 0.5, right? Then in the intersection may be 0.5, but that may be called, okay, disjointness according to this one, right? Can you follow? Mu you take 0.5 and nu also you take 0.5, right? Then in the nu complement it is 1 minus, that is the development, you know. Therefore, 1 minus nu of x is nothing but again 0.5. Therefore, this 0.5 is less than or equal to 0.5, right? Therefore, this mu and nu is again 0.5. So both the same set, sometimes they are disjoint according to this definition, right? But it is not, okay? Therefore, so this the second one does not imply the first one, and the first one imply the second one. That is the concept it is given, right? Okay. Now, again, so image of the fuzzy set and inverse image of the fuzzy set is also important to study the continuity and fuzzy continuity. Okay. Therefore, if you are given with mu a fuzzy subset in X, then f of mu, it is a fuzzy subset of Y developed by f of mu of Y equal to this way, right? So that is supremum of X belongs to f inverse of Y, right? Suppose you take here Y. So for every Y you are going to develop f of Y a function. Therefore, for a given Y, the inverse image you find out, right? The inverse image under f is empty, then it is 0, right? If it is not empty, then for those points you take membership grades in mu, and it's a supremum you take it. That is the value corresponding to our Y in f of mu, right? Similarly, f inverse of mu, it is a fuzzy subset defined on X for a given mu in Y, defined by f inverse of mu of X belongs equal to mu of f of X for every X belongs to capital X. Okay. So this is again important preliminary I want. Okay. Then we have further discussion, right? So it is F invariant. The F invariant is nothing but generalization of the 1-1 map, actually, right? So the things which are available in 1-1, so the same thing here also we are going to take for the function and set, right? So f is called mu invariant if f of x equal to f of y, right? In 1-1 x equal to y, but here it is guaranteed that only mu of x equal to mu of y. Okay, so that is the thing for f invariant, right? So this f invariant is somewhat imitate or generalize the concept of 1-1, right? So from this note you can see. Right? So in 1-1 map, mu equal to f inverse of f of mu. This will come, right? But in general, mu less than or equal to f inverse of f of mu only. That means a subset of f inverse of f of a, right? It need not equal to equal, right? So when they are equal, only if 1-1 map, right? But if mu and you are mu invariant, f invariant, that case also you can have, right? Therefore, some property which are available for 1-1 may be replaced by with this weaker axiom or weaker condition f invariant. That is the idea behind that. Okay, right. Now these are the preliminaries I want to study for. Or I want to give, which is useful for the further discussion. That is why it is all given. Okay. Shall I go to the next thing? Right. So it is fuzzy topological spaces. Right. This is the title it was given. Right. So in the topology, what it is? So we are given with a non-empty set, and so we are going to collect the collection of fuzzy collection of subsets of X, which satisfies the three axioms. One is empty set and whole set, it belongs to that collection, and arbitrary union of members of the sub collection, given collection, is again a member of that collection, and of the finite members of the section is again member of that subcollection. So this is the start point for topology, you know, right? So topology is a study of set theory, right? So we are given with X and the P of X. From the P of X, we are collecting a section. That subcollection obeys some rule, but three rules. The first must be the member, right, of the again in the sub. Right? and you take it and interest that particular collection. So based on made in the first, so I have fuzzy subset, right? So therefore, instead of power set here now with three property type of things. Why 0 and 1 is imitating the empty set, right? The functional with that for any x, a of x, 0 they are resembling one, but the correction, right? Therefore, nothing but the empty set and the particular collection. Members of any, so it is imitation one. What is the meaning of intersection? That is minimum, because we are talking, right? That it gives only mu1, mu2, that mu1 comma mu2 comma mu. This is of any subcollection. So that means here arbitrary. So here is taken. Maybe you think over by superior of any subcollection sigma subset number of delta, right? Therefore, this emphasis, right? So yes, fuzzy topology X, which is nothing but it is the collection, right, or subcollection of the fuzzy power sets, right? Fuzzy sets, the collection of all fuzzy sets with this property. Okay, right. Now, as in our topology, over the fuzzy topological spaces, then of course members of the fuzzy topology are called fuzzy, and its complement is called fuzzy closed. Okay, so the imitation remains still there. Here talk about the discrete topology and discrete topology. Right? Discrete topology, fuzzy topology means only singleton and sorry, 0 and axiom with the first one is taken. Right? In this also the same way. Right? That means said only taken in the topology, then it is called in discrete topology whole set. That is 0. In the discrete topology, okay, then it is called topology. Right here also for the base form. It is not required to define all the time delta, and therefore by omitting the third condition, right, I can develop with the base, right? So the subcollection of delta is said to be base if each member of delta can be expressed as a union of members of sigma, right? So this is again valid in the topology. From there only it is taken, right? Similarly, subbase also it is possible to develop. Okay, so subbase means what? So it is a collection we are taking from delta, right? And whose finite collection of possible finite intersections makes base, right? So that is the development, right? So the same way it is also developed. Of course, this development and all was done by C.L. Chang in 1968. Okay, so Zade he developed fuzzy set in the year of 1965. Once the mathematical structure is defined, then automatically, so the other mathematical structures can be possible. That and all they have developed. Okay, so one way is fuzzy topology. Right? Some people they are querying about it is only the topology of fuzzy subsets, of course, right? So that is why it is called I topology. Some people they used to tell, okay, because it is a function from x to 0, 1, right? 0, 1 is nothing but I, right? So based on the things they have developed, okay. So some people, right, Sostak and all they have developed some other way, right? So they are developing a Sostak fuzzy topology, right? The Sostak fuzzy topology is nothing but it is a function defined on the power set of x. right? So for each fuzzy subset, they are going to give grade. So where empty set and whole set are completely a member. Therefore, they are going to give the function from the fuzzy subsets of x2 close interval 0, 1 with the membership grade value, membership grades for empty set and whole set is 1. And the other things, okay, the finite intersection means it is greater than or equal to minimum, and supremum is greater than or equal to supremum. Okay, so in their entire talk, so I am sticking on only the topology of I sets or the Chang's fuzzy topology, right? So in the Chang's topology again, so this is all interior and closure. It again imitates the definition of the interior and closure in our topology, right? So it is nothing but largest open set within mu, and this is a largest smallest closed set containing mu, right? Of course, when you think over again, right, by means of with software, then it is then flag is given with 90. Mathematically, these, right? So therefore, we start with the interior. It is called fuzzy. Fuzzy interior is given by concept contained in the closure. The fuzzy closure is given by smallest fuzzy closed set contained of nothing but the open sets, right? And it is the closed sets with, right? So of course some preliminaries it is right? Now subspace topology, right? And x delta is topological space. That's true. So I can think over the function from x1 that may be, that is the right. It is a collection of all subset. That is the meaning. Restrict the function to y. Okay. So this here. So delta is a function 0 and restrict y function 0, right? So that is called subsets, right? Then fuzzy fuzzy open, fuzzy holism, everything is possible, right? Which is again imitation the of continuous function open and homeomorphism. So this slide here, it is definition is done. Okay. Then topological property. Then the topological property imitated here fuzzy topological property, right? So fuzzy topological property means what it is. The property which is preserved by the fuzzy homeomorphism is called fuzzy topological. So similar in our topological property, yeah, but it is preserved by topology topological property. It is by fuzzy homomorphism. Right. So again, it is similar to that one point. So the function is because the function is to be fuzzy first. It is continuous. If only every point, it is important point. It is fuzzy, and every new direct open set containing the formula new. The belonging is important. So of substance when you think as a point in the, so these are you have to take it in your mind. Okay, fine. Now on to the next definition. It is called again initial fuzzy. So initial fuzzy topology is obtained by a collection of functions, right? So suppose I am given with a collection of functions from x2, the topological space is yj comma sigma j, then I can have a topology in x in which each fj is continuous, right? Which topology I am calling initial fuzzy topology? The smallest topology among them, right? You may be knowing, right? Any function from x2, this topology is continuous if x is What would be x? If x is a discrete space, then obviously any function is continuous only, right? Then discrete spaces exist with this property. For fj, all fj is continuous. But the smallest topology in which you are having this all fj is continuous, it is called initial fuzzy topology, right? Similarly, suppose you take the function from here topology and here function, right? So here set. For example, fj from x delta to y. Then here, y I can think over a topology which is largest topology for which fj is continuous called the final fuzzy topology, right? So these are all again elementary, by which only here, if you take instead of fj, if you take the projection map with here x's product yj, then it is a product topology will come. Okay. So here it will lead to the quotient topology we have, right? So these are all something which lead to the study of the other things, right? So here you see this initial topology is the framework by which the product topology is defined, right? The product topology you can think over by basis and sub-basis, right? Another way, if this projection you take it, right? The projections are all continuous in the same way. If you think over the topology on X, the product X alpha, then that is nothing but our product topology. Therefore, using this initial topology also I can think over, right? Therefore, this product X alpha, product delta alpha is nothing but it is the initial topology for the projections, right? So from product X alpha to X alpha, that is the meaning, right? Similarly, the quotient topology also. Right? So this is the thing again, quotient topology, right? When we think of quotient topology, then I assume the surjectiveness, right? So surjectiveness is that x and y are given, right? Here x topology is given, right? The domain is with the topology, fuzzy topology. The codomain you are going to develop a topology, fuzzy topology, right? By taking again the largest topology on y for which f is continuous, right? That is our quotient fuzzy topology, right? So using that final topology, I can study. That is the meaning here, right? For any collection of functions, I can study with the final topology, and that final topology gives a quotient topology on y. Okay. Now it is another study. It was done by Lowen. So Lowen, he developed this type of things. Okay. For a given fuzzy topological space, can I find a topology induced by this fuzzy topology? Right. The similar type of for a given topology, right? The second one, it is x tau is only a topology, right? For a given topology, can I think over the fuzzy topology, right? So that type of things, these two definitions, right? So we are given to 1.2.10, we are starting with the fuzzy topological space, right? From this fuzzy topological space, they are going to take alpha comma infinity with alpha belongs to R, right? So tau equal to empty set and whole R and open alpha closed infinity. Of course, it is not closed infinity, open infinity only. It is a typographical error again. So open infinity, right? Then only the subset of R, right? So if you take this way, then it gives a topology on X, right? The tau is a topology, right? Therefore, this is called, right? So induced topology on X. By a given fuzzy topology, I am coming to topology, right? Here in the next definition, for a given topology, I can come to the fuzzy topology, right? That is the way here, right? So now, from these two definitions, right? So Lowen has studied something related to that, okay? And he has studied the topological generator. When a topology, fuzzy topological space is said to be topological generator, right? So usually the induced topology, right? You see tau is our given topology, right? For a given topology, where you think over the induced fuzzy topology. For the induced fuzzy topology, again you go for the topology, that is induced topology, right? Then if it is equal to tau, right? It is usually done, but in the reverse way, instead of starting with tau, so if you start with delta, right? The fuzzy topology, for a given fuzzy topology, I can think over the induced topology I of delta. From the I of delta, it is a topology, therefore I can study of again fuzzy topology, that is W of I of delta, right? Now these two are not same. I started with the fuzzy topology, right? And this I of delta topology, then again fuzzy topology. But these two fuzzy topologies are not same, right? When they are same, if it is only topological generator, that is the meaning, right? So for a given fuzzy topology, if there is a topology exists with W of I of delta equal then we call it is topological generator. Okay. So then the next one, so whenever we go for the study of topology and all, then obviously we study of the convergence of the sequence, right? So based on which, when you think over the fuzzy sequence of fuzzy points, here it is important fuzzy points, right? So when you think over the fuzzy points, sequence of fuzzy points, then the sequence set to converge to a point, again fuzzy point P, right? Provided as usual, okay, any open set, right, containing this mu, right? Mu belongs to delta such that P belongs to mu, right? Therefore, any fuzzy open set containing mu, this containment is strictly less than, right? There exists a number m such that Pn belongs to mu. It is again imitation of the convergence of our classical sense, right? But it is only difference is it is dealing with the collection of fuzzy points, right? Sequence of fuzzy points, and it is the limit is also a point, fuzzy point. Okay, so it generalizes the concept of sequence of the convergence of the sequence in the classical sense also, right? Because this sequential fuzzy point is generalization of the sequence of points, Therefore, this definition is more general than the existing definition of the convergence of the sequence in the classical sense. Okay. So now in the whole things, so we started with the fuzzy topology and the different types of fuzzy topology and the main frames of sequence convergence, right? That and all we have studied, right? So the 5 pages, these are the base we have, right? And some continuity functions and all we have started and studied. Okay, right. Now, so using these fuzzy topological spaces, right? Now I have covered almost all fuzzy topological spaces, right? So from this concept, so how the separation axioms and other things can be developed. Okay, so that is the idea of this particular study, right? Right. Now, so when we think about research, right? So when we think about research, so we have to think about how they are studied in the existing setup. And that is very much important, right? So that is the important thing for developing into the fuzzy sets, right? So extending the notions from crisp set to fuzzy subset, that is important, right? So that is the way we have developed the continuous function to fuzzy continuous and the intersection to the fuzzy intersection and further generalization and all, right? Therefore, whenever we think about the movement from crisp setup to fuzzy setup, right, it can have different definition. That is important, right? So for intersection, the standard intersection is one definition by which minimum or infimum is given, but you see infinitely many intersections are available. They are all called T-norm in our basic fuzzy set theory, right? So T-norms are nothing but they are all generalization of our intersection in the classical sense, right? So for one definition, intersection in the set theory, but infinitely many fuzzy intersections are available in our fuzzy sets, right? Similarly, so when we study about, okay, the topology and all, already I have told one is Chang's topology, another one is Shostak topology, right? So similar way, so here also we are going to study the separation axioms in different way, right? So the separation axiom, what are the things? It is basically the parameters involved that we have to think over in the classical sense first of all, right? In Hausdorff space and other separation axioms, they are all involved with crisp points and closest sets, right? So first you think over for Hausdorffness, then that may be imitated to the regular space and normal space and other things and all, right? So you think over for Hausdorff space, right? In the Hausdorff space, what are the things it is involved? What do you mean by, first of all, Hausdorff space in our topological sense? Right? So whenever we are given a topological space, x delta or x tau, right? For every distinct point, x and y, if it is possible to identify two disjoint open sets, which contains those points separately, right? So if that happens for every pair of distinct points, then we call it is Hausdorff space, right? Like that is the definition, isn't it? Right? So x tau is the topology, right? Or topological space, and for every pair of points x and x comma y with x not equal to y, if there exists u and v such that x belonging to u and y belongs to v, and u intersection v equal to mt, right? So therefore, what are the parameters involved in this particular host of spaces? Right? So it involves with the points, right? 2 points x and y, and it involves with the open sets, and it involves with the disjointness, and of course containment also. Because whenever we think over point, then automatically it is involved with the containment also, right? Therefore, already we have seen different generalization of the points, that is fuzzy singleton and the fuzzy point, right? And the containments according to that. Okay. At the same time, we have different disjointness, right? That also in the earlier slides I have shown, right? So one is mu and nu are disjoint if mu cap nu the minimum equal to 0. The another one is mu less than or equal to u complement. Okay. So therefore, for each the definition in the classical sense may be generalized in the different way. Why it is happened? So we are traveling from the subcollection to the higher collection, right? Because any subset is again a fuzzy subset. Therefore, the collection of all subsets, the power set of X, right? It is a subset of the collection of all fuzzy subsets, right? Therefore, the collection of subsets or the power set of X is a smaller collection. It is compared to the collection of all fuzzy subsets, right? Therefore, we are developing continuity, right? From the smaller to higher, then automatically I can think over it a different way, right? It should be restricted to the smaller domain, then it should be true for the topology, right? That is the way we usually think over, right? The topology and fuzzy topology, you take it, collection of all topological space is a subcollection of collection of all fuzzy topological space, right? Therefore, the axioms and the properties which are available for a smaller collection, when it is generalized to the higher collection, then automatically it leads different definitions, right? So that is the way, right? So in the separation axioms, I have three parameters. So these three parameters only we are going to think over, by which the entire different ways of development of the house softness is done. Right? So this is the 3 points, right? So points and open sets containing points and the disjointness. These are the 3 entities it involved in the house softness, right? Then I can generalize the points into fuzzy point and points into fuzzy singleton and open sets into fuzzy open set and containment by strictly less than or less than or equal to and disjointness by different. Okay? Therefore, for each one, right? Now you think about the different combinations, right? So those combinations use different house softness definition, right? That is the way it is all developed. Okay. The first person, he started with the development of the fuzzy house softness by taking a crisp point, right? And the disjointness is with the intersection is empty, right? That means a cap b equal to 0, right? So that type of thing only he has taken, right? And the point is taken as the same point, x and y, right? Then x and y is taken, but when it is said to be a point, is said to be said to lie in a fuzzy subset. That is the question, right? X is a point, it is a crisp point, right? It is taken from capital X, the inverse of discourse, right? Mu is a function from x to 0, 1. Then we ask when the point x lies in that particular mu, right? So that is the development, right? Then we usually think over, so completely line, right? Complete line means what? Mu of x equal to 1, right? Therefore, so here the points are taken with the x and y, the general classical points, and the containment is taken with the mu of x equal to 1, right? And disjointness is taken with the mu cap mu equal to 0, then by which one house softness, fuzzy house softness, they have developed. Okay, the fuzzy topological space x delta is said to be fuzzy house soft. If for every pair of points, here it is only crisp points, right? It is not any fuzzy point. Pair of points x and y with x not equal to y, right? And the containment is given by mu of x equal to 1, and existence with the fuzzy open set mu and nu with mu of x equal to 1, that means x belongs to mu, right? And y belongs to nu with the mu cap nu equal to 0, that is emphasizing the disjointness. How it is easy to develop one new notion, you see. Right? So just I have studied the parameters of the house softness, right? By studying the parameters, where and all it is possible to think over the fuzzification that I am doing, right? By which, okay, this fuzzy house softness is developed. Okay. See here, the point is taken as it is, and only the belongingness is taken as with the cradle value with 1, and the disjointness is with taken as empty when you take intersection, then that is the disjointness. Okay. So this is the first version of the fuzzy house softness. It was developed. Okay. Then later on, so then it is one by one they are trying to imitate and generalize the concept. Okay. Then the obvious question, so we are talking about fuzzy topology. Then why should I talk with the two distinct general point or classical point? Why don't I think over the fuzzy point here? Then I can think over here fuzzy point, P and Q. So two fuzzy point, when I think over P and Q, by the definition of fuzzy point itself, it has only singleton support, right? Therefore, P is defined only at X, at other point is 0, right? And Q is defined at another point with all other point the greater value is 0, right? Now, the question is, when two fuzzy points are said to be distinct, because it is required to have not only two fuzzy points, but it should be distinct, right? Then the question is, when did the two fuzzy points are distinct? Right? Then, if you have the underlined fuzzy, underlined singleton, right? If it is the same, then how it can be distinct? You see, P and Q are taken two fuzzy point. They have underlined point X only, right? That means it has singleton support at X. Right? Then only greater value is different, P of X may be greater than, or P or Q of X may be greater than, right? But anyway, they are developed with the singleton X. Therefore, obviously, either P less than or equal to Q or Q less than or equal to P, right? Therefore, I cannot tell P not equal to Q, right? Therefore, so P not equal to Q is possible only if this P and Q are developed with the different supports, right? So that is important. So that understanding we have, right? So based on which, okay, so distinct fuzzy point, the meaning is written. So this is the development of fuzzy point. Already I have told, right? So it is a ordinary singleton, right? At the from the singleton, we are going to develop with the. So here some mistake, I hope. Okay, z not equal to x, it should be 0. At z is equal to x, it is 1. Okay, so it is unfortunately it is wrong. Right? So it is equivalent to characteristic function on singleton x means at x it should be 1. At all the places it is 0. It is a small typographical error that you correct it and think over. Right? So this is the characteristic function on singleton x. It is only imitated by taking value instead of 1 with open 0, open 1 in fuzzy point. Okay? So in the fuzzy singleton, it is with open 0 to close to 1. Already I have told, right? And the containment is nothing but less than or equal to. In the earlier preliminary itself, I have already told. Okay. Now here it is a fuzzy singleton. Two fuzzy singletons are taken, and the containment is developed. And so when they are said to be distinct, that also we are going to take it. Okay. Of course, it is the development of fuzzy point and all. Already I have done it. Okay. So now I have fuzzy point, fuzzy singleton and all that. In this particular definition, okay, again he is developing fuzzy Hausdorff, but it is started with the fuzzy points P and Q. But whenever we have fuzzy points, then obviously the support must be distinct. Then only P not equal to Q I can tell. Otherwise P less than or equal to Q or Q less than or equal to P will come. Therefore, the distinct support is required. That is also assumed. Okay. Then for every pair of fuzzy points with the two different support, okay, there exists again fuzzy open cell mu comma nu belongs to deltas is that P belongs to mu and Q belongs to nu with P, mu cap nu equal to M2. Right now you see from the earlier definition only X and Y is removed and it started with the two fuzzy point P and Q. Whenever we have P and Q, then the containment instead of mu of x equal to 1, I am taking P belongs to mu. The meaning is P of x is P less than mu of x. Okay. So this is imitated. And of course, this is retained as it is. Right? Therefore, the disjoint is retained as it is. The point is made into fuzzy point. Okay. So small change only it is done. Right? By which the new study of fuzzy softness it is done. Right? Then obviously, so why should I think over this mu cap nu, right? So I can think over another disjointness, that is A subset of B complement. This is also another way, right? So this is the base for developing mu less than or equal to nu complement, right? Therefore, from this definition only it is started, right? Therefore, two fuzzy subsets are disjoint if mu less than or equal to nu complement, right? So this is accepted. So by which again another house softness, why don't I think over, right? So that is the idea here. You see, the fuzzy points remain same. Right here, I didn't change any here in the from the earlier definition, and hence the belongingness is not required to change. But only thing this disjointness is changed. Right? Therefore, this will give another type of Hausdorffness. Right? Then obviously I have three different Hausdorffness. Then it is all developed in different time period by different people. Right? and they usually compare with the existing. Right? So that is the way it is all developed in research. Right? Therefore, fuzzy homogeneousness as per 1, it is again fuzzy homogeneousness as per 2. The meaning is, so this one is the generalization of this particular concept. Right? So that is the way, A implies B means B is the generalization of the A. Right? Therefore, this concept is a generalization of this concept. Similarly, so the third concept is also generalization of the first concept. Now the question is whether these two are having any relation. No, they don't have different relation, right? They have no relation at all, right? So or otherwise, one is redundant of the other, right? Therefore there is no importance of the study, right? Therefore they have developed, that is the importance of the research, right? So we are doing the research, not only just imitating, at the same time the justification is also important. Justifying how the definition is important, right? Therefore, this third definition they have done with this way, right? So this third definition is a generalization of the one, and there is no relation between this fuzzy homogeneousness 2 and fuzzy homogeneousness 3. Now you see, so fuzzy homogeneousness is there, right? Again, can I think over further homogeneousness, right? So 3 parameters is taken. Among the 3 parameter, point is already fussified. Then the disjointness is fussified, right? Mu of x equal to 1, that is taken with respect to the fuzzy point. But still, the containment or the belongingness is not generalized. Now you see, the containment is taken here. Right? So the definition states a point x is said to be said to lie in the fuzzy subset mu if mu of x is greater than 1 by 2. By usual numerical way, we think over greater than 1 by 2, it is considered as 1, therefore it lies in mu. But that is not the actual meaning of this definition. Right? It can be viewed that way in usual understanding, but the definition is coined in another way of importance. You see, suppose I have x in the domain universe of this course, and mu is a fuzzy subset. Right? Then when I can tell x belongs to mu, usually suppose the x has membership grade. Right? Once I have mu of x is membership grade, right? Therefore membership grade is there. At the same time, I can think of non-membership grade. What will be non-membership grade? There is 1 minus of mu of x. Right? So that is the standard complement by which the standard non-membership I can think of. Right? Therefore, mu of x is a membership, and 1 minus mu of x is non-membership. Right? Then when I said to lie in mu, if membership grade is greater than non-membership grade, and then I tell he is belonging to mu. Right? Can I follow? Can you follow then? So membership grade, if it is greater than non-membership grade, then only I can tell he is a member. Therefore, mu of x must be greater than 1 minus mu of x. So mu of x greater than 1 minus mu of x implies, left hand side you move it, 2 times mu of x is greater than 1. Therefore, mu of x is greater than 1 by 2. This is the base for development of this definition. Right? It is not simple with as in our greater than 1 by 2. Right? So this is obtained by means of it is said to be lying in mu. Therefore, the membership grade must be greater than the non-membership grade. Right? So that is the ultimate importance. So now these belongingness is generalized, right? Using that concept. Right? Once I have belongingness, again I can think over 2 classical points with this membership grade and all. Therefore, using this, we have another generalization. Right? So this is generalization. Therefore, we call it is nearly fuzzy homogeneousness. Already many fuzzy homogeneousness is there. Therefore, we feel it is a nearly fuzzy homogeneousness. Right? It is the generalization of the fuzzy homogeneousness. That means fuzzy homogeneousness implies this one. Right? That is the idea. At the same time, so one more reason for developing nearly here is here the singleton may not be closed. Right? Therefore, in homogeneousness, we in T2 particularly, so we expect the singletons must be closed. Right? Therefore, if the singletons are not closed, then we call it is nearly fuzzy homogeneous. And where the singletons are also closed, then we call it is fuzzy T2. Right? That is the way the things are developed. Therefore, the nearly fuzzy homogeneous space, how the definition is coined, it is a 2 point is taken. The 2 points are classical points. Of course, it is distinct, you know the reason, right? Then there exists a disjoint open set. Here disjointness is taken by means of this mu of z plus mu of z less than or equal to 1. It is nothing but imitation of mu less than or equal to mu complement again. At the same time, it is imitation of this definition also. Right? Members equate less than or equal to the complement of the other. Okay. Therefore, so using this disjointness and this belongingness, and for any two distinct point, if you have, then we call this is again fuzzy Hausdorff space. Right? How the things are done easily, you see. Right? So, but when you think of after the development, it is all easy, right? Looking like easy. Right? So the fuzzy logic also you can think of, right? What it is done, only the two sets where 0 and 1 are taken and removed with the close interval 0, 1. Right? But this definition was kind after 2000 years. Right? Once the development or definitions are done, then the people may criticize what is due in that. Right? But once the development is very important, right? How the things are done. Now, based on which the new development it is done, now you see this development, it is with the 2 implies this 4 definition and 3 implies 4. The meaning is okay, it is a more generalization, right? With respect to 2 and 3 and 1, everything. Okay. Therefore, this is the concept which is generalization than all the other fuzzy Hausdorffness and all. Right? At the same time, okay, the other properties in the earlier fuzzy Hausdorffness, some of the properties are not studied, but in this particular development, all the properties, okay, about fuzzy subspace and product, okay, productivity is there, you know. So in Hausdorffness, that is also involved, and okay, the convergence also you can study, right? Then you have to limited the convergence by means of our belongingness, right? So this mu of x greater than 1 by 2 means what? X belongs to mu, right? Therefore, the belonging based on this new belongingness, this definition is done, right? Then based on this development, okay, what is the meaning of okay the Hausdorffness? The Hausdorffness always implies the convergence of sequence uniquely if it converges, you know, right? That is also here it holds. Therefore, in a new NFT2 space, any fuzzily converging sequence of points converges fuzzily to a point uniquely if it converges. Right? The uniqueness is there. Right? But the converse need not be true. Once we have the converse need not be true, my teacher, my guide, usually you are used to take as a positive mode. Right? So he asked you us to feel happy. Right? Because from there I can go for a new definition. Right? So wherever the converse, if it is there, then it is equivalent. I cannot go for further. Right? But when the converse is not true, then I can think of a topology in which converse is also true. Then that topology may be given with a new name. Okay, that development is already in the topological sense was done by Nayambali Somasegar. Yes, Nayambali. Right? He has developed with the semi-Hausdorff space. The semi-Hausdorff space is nothing but the topology in which the convergence is uniquely done. Right? That means Hausdorff space is a semi-Hausdorff space, but the converse will not be true. Right? So in the topology, the same way here also it is done. Right? So in the nearly fuzzy Hausdorff space, the convergence uniquely is there, but the converse need not be true. Right? So it is seen from the following example. Right? So of course it is imitation of our the countable complement and all, right? Uncountable set you are going to take, and a countable complement topology is imitated here, right? So by which we are getting fuzzy topological space. Then here the sequence does not converge. No sequence converges to any point. Therefore, it is vigorously true that it converges. Then only it is uniquely required. You know, it has no convergence at all. Therefore, I can think over this is converges uniquely, right? Therefore, this is converges uniquely is there, but it is not fuzzy Hausdorff space, right? So here you see, whenever you take 2 points, right? So x and y, then there is no disjoint open sets which contains x and y. Containment here means mu of x greater than 1 by 2 and mu of y is greater than 1 by 2 and mu less than or equal to mu complement. With that, I cannot find, because that is the way it is developed this example, right? That is why it is taken x is uncountable and it is with a countable support, right? When I have mu and nu, 2 has only finite, that means the complement has finite support, means the countable support means what? Right? There are uncountable point in which mu complement is 0. Right? Therefore, uncountable point in which mu equal to 1. Right? So that is the ultimate discussion here. Right? Suppose you have two mu and nu, then mu complement has countable support because mu and nu are open sets, right? According to the definition. Right? Therefore, if it is open and disjointness is there, then automatically it is problem because it is uncountable. There are infinitely many points in which mu and nu takes the value 1. Therefore, it cannot be the disjoint one. So that is the discussion here. Right? Therefore, here in this example, so we have done, it is not a nearly first Hausdorff, but the sequences converges uniquely, right? That is the thing. Therefore, the Nayambali, right? Already I have told Nayambali, he has studied this type of things in his research paper with semi-Hausdorff spaces. Right? The semi-Hausdorff space, according to him, is a topological space in which the sequences converges uniquely, if it converges, right? Or otherwise at most one point. Right? So if it converges, uniquely converges means if it is not convergent, then we cannot have limit, that may be replaced with at most one point. That is the way he has developed. Okay, Nayambali. The same type of things it is also taken here, by which the semi-nearly fuzzy Hausdorffness is developed. Okay, so according to the new definition, the semi-nearly fuzzy Hausdorff space is nothing but the fuzzy topological space in which the fuzzily convergence is uniquely done, or at most one point is done. Okay. So this is all under Hausdorffness. Then the similar way of development in fuzzy regular space and fuzzy normality, the similar way of in regular space again, you think over it is also involved with parameters, right? Point and closest set and disjointness. Right? The point does not belong into the closest set. Right? So based on which you can develop. Right? At the same time, it is a property of the regular space in the Mandras book. Okay, that is taken. Right? So in the different characterization they have done, based on which fuzzy regularity they have developed. Okay, so this is one fuzzy regular space, another fuzzy regular space. Here you take fuzzy Singleton and a fuzzy closed set. Okay, P less than or equal to mu complement only makes P does not belong into mu. Right? So you see, right? So everything they are imitated in a nice way, right? By different authors, right? In literature, and based on which fuzzy regular space is done. And here again, right? So instead of taking that disjointness, another disjoint may be taken. Okay. So in the same way, these are all developed. Okay. Now in the same way, I can think over the new nearly fuzzy T3 also. Here again, a point and closest set is taken. A point is a classical point and fuzzy closest set. Right? And again, it does not belong into mu. Therefore, I take it is less than 1/2. Right? It is equal means it is neither lie nor belongs. Okay. Therefore, I take less than 1/2 for not belongingness, and again it is imitation again. Right? This joint fuzzy open sets and which contains X and that entire closed sets. Therefore, mu less than or equal to gamma. Can you follow? It is easy. Right? So gamma 1 and gamma 2 are two open set, fuzzy open set. This gamma 1 contains the point X. Containment is greater than 1/2. Right? And containment of the set, it is both are function, therefore mu is less than or equal to gamma 2 is assumed. Right? This is called nearly fuzzy T3 space. Right? Again, it involves with the other properties and theorems and all. Right? So a fuzzy regular space is a nearly fuzzy regular space, and again it can have closeness. Singleton closed also it is possible, right? In Singleton closed in some sense. Right? It is generalization of the again and the Singleton of our classical sense. Right? The meaning is there exists fuzzy closed sets with the Singleton support and greater than 1, the Gradle value. You see, right? So, see, usually the closest Singleton close means what? So the complement is open, right? So the complement is open with the belongingness means 1. Right? It is imitated here, therefore greater than 1/2 also we are taking. Right? Therefore, if you think about A and B two set points, then at those points A and B, the Singleton close is given by, you see mu A B 0, y. Right? So what is the complement here? At A it is 1, at B it is 1 minus y. Right? At B it is 1 minus y, at A it is 1. Right? Therefore, what would be the support here? Support is in the new complement. Okay, in the new complement, support is here A, and B is also there because it is 1 minus y. Right? Y is taken here between 1 by 2 1. Right? Therefore, this complement will not give the singleton closed. Right? But you see here this mu x comma 1. Right? So what would be the complement now? Right? So not here. You take it with 1 comma y naught and x naught comma 1. Yeah, you take this one. Right? So now what will be the complement? 1 minus x naught and 0. Right? 1 minus x naught and 0 means A has general value 1 minus x naught and B has 0. Therefore, they have singleton support. And this 1 minus x naught is greater than 1 by 2. Right? So it is a idea we have developed. Okay, x plus x naught equal to 1. And x is greater than 1 by 2. Right? Therefore, 1 minus x naught is always greater than 1 by 2. Right? Because x naught is 1 minus x and x is already greater than 1 by 2. Therefore, this x naught is less than 1 by 2. Therefore, 1 minus x naught is greater than 1 by 2. That is taken. Right? Therefore, at A, right, the complement has only singleton support with the greater value greater than 1 by 2. Therefore, we call, right, this is singleton support. This singleton is closed. Right? That type of thing is possible. Therefore, this N of T3 may have closeness also singleton. Then we call by including these two with FT3. Right? So that is a development. The fuzzy T3 or fuzzy regular space is nothing but N of T3 in which singletons are closed. Right? The same way, FT2 also it is possible. Right? So these are the things. Again, you can generalize to the another concept of further generalization, inducing fuzzy topology and all. Right? Inducing fuzzy topology is the development of the inducing fuzzy logic based on which the inducing fuzzy topology they have developed. Okay, the Poker he has developed this concept. Then here also you can think over the type of separation axioms and all. Right? So this is again further generalization. These are all in the topic of separations we are separation axioms we are talking. Okay. Then further we have fuzzy filters. So fuzzy filters, filters you may be knowing, right? What do you mean by filter? Right? So it is again collection of subsets. Right? It's a sub collection of power set of X with some axiom, right? Empty set cannot be a member, and whenever a member is there, then any member greater than that must be a member, right? And intersection of two member, again, it is belonging to that type of things, the same way the fuzzy filter is also developed. Okay. Right. So fuzzy filter means you see there is a collection of fuzzy subsets in which a empty set is not belonging to, and whenever I have a two member, then intersection must be, and whenever I have one member, then any member greater than that, it is again belonging, right? Therefore, it is called a fuzzy filter. The important thing is in filter theory, I don't have any Hausdorffness and separation axioms, right? Because in filter theory, intersection is again member and zero cannot be, the emptiness cannot be member, right? Therefore, disjoint open set is not possible. Disjoint members cannot be member of filter element, right? Can you follow? Right? So here, mu and mu, if it is there, then intersection must be there. The intersection cannot be empty because emptiness cannot be belonging, no? Right? Therefore, intersection must be belonging with zero not belonging to means the intersection cannot be the empty, right? Therefore, disjoint members of the fuzzy subsets cannot be member of the filters, right? In filter theory, right? But in fuzzy filter, it is possible to have, right? Because of the disjointness given by mu plus mu less than or equal to 1, right? Therefore, this is the filter, right? Fuzzy filter. But here you can have the disjointness also. Right? Therefore, here the disjoint members can be the member of the fuzzy filter. Right? Therefore, here I can think over all the separation axioms. This is the beautifulness of this particular concept of separation axioms on the fuzzy filter. Right? So usually the people they used to ask, right? When we go for the generalization, then any interview and anywhere they used to ask, tell a property which is not available in classical theory, but in new theory. Right? The other side usually we do, right? That is a generalization, right? So the property which available in classical sense, it is generalized to the concept of the new theory, right? So therefore, the property available in the classical sense, and it is made to the new theory, right? But the reverse side, it is usually we don't, right? So the property which is available in the new theory, but it is not in the usual theory, right? So that is possible in this the separation axioms of the fuzzy filter, right? This is added advantage of study of the fuzzy filters and its characterization, right? Then again, host of fuzzy filter, semi-host of fuzzy filter, that type of similar things can be possible in the filter theory, right? So this is the new idea, right, which is not available in the classical sense, but it is available in the new theory of fuzziness, right? Then again, it is another type of study. Okay, already the time is what's the time? Maybe it is 1:30, right? So therefore, further development and all, I stop with this level, right? It is induced topology means so the collection of fuzzy singletons I am going to take. There I am going to talk about the topology, right? From the fuzzy topology, right? Just I show the definition if you want, maybe useful for your further studies and generalization and research, right? So you see here, we are developing from the fuzzy topological space, right? One topology we are developing, but the topology are not X or G, right? So it is developed on the collection of all fuzzy singletons. That is the importance here, right? Collection of all fuzzy singletons, you take it, okay? Even if G is a finite set, then the collection of fuzzy singletons, how many, it is uncountable, right? Because the codomain set we have 0, 1 uncountable, right? Any function from the finite to uncountable, it makes uncountable functions, right? Therefore, this P of G is always uncountable, right? There we are talking about the topology, right? Based on the fuzzy open sets in the fuzzy topological space, right? So how it is done? So it is a imitation again, right? So see the open sets are the basic sets I am going to develop for each open set, fuzzy open set in delta, right? For each mu belongs to delta, I am developing V mu. The V mu is nothing but the collection of all fuzzy singletons belonging to mu. That's all. Small idea, right? The Spark only made the new research, right? So mu is a fuzzy open set. Within the fuzzy open sets, I have the collection of fuzzy singletons. What is the meaning of within the fuzzy set collection of fuzzy singletons? The fuzzy singletons which belongs to mu. Belongingness already the P less than or equal to mu, right? That collection you collect it, right? Then that makes one set, this is a sub collection of the fuzzy singletons, right? That type of sub collections you take it, right? Then that sub collections makes basis, right? From the basis you generate a topology, then that topology is our induced topology on fuzzy singletons, right? Why it is required? This study is very much important to study the translation invariantness and further generalization to the topological vector space and all, right? So for this topology is studied, right? So that idea is okay, very easy when you think over after the development, right? So mu is an open set. From the mu, you collect the collection of all fuzzy singletons, and this V mu collected. It is all collections, subcollections of the power P of G, right? Then that makes again basis. From the basis, you know how to develop a topology. That topology you take it. Okay. This topology, right, is called induced topology from the given fuzzy topological space, right? From this you can study a lot of things. Okay, again whether this gives a discrete topology, right? Suppose for any fuzzy topological space, this topology, if it is always discrete, then there is no importance. That definition from the definition that idea is developed. Okay, this is not a discrete topology. That type of things. The example is given, right? Then whenever I have a new topology, then I can study, okay, what is the relation between this fuzzy compactness and this compactness, right? Here it is fuzzy compactness means you may be understanding, right? The collection of fuzzy open sets and its covering which admits the finite subcovering and all. Here it is a ordinary compactness, right? So this way you can, the converse need not be true again, right? The example is given. Then Hausdorffness you can study, and of course connectedness you can study. But when you think of the Hausdorffness, here only pseudo Hausdorff I can study in induced topology, right? Why? Of course the same way, right? I can have two fuzzy singleton which are not equal, means not only at the values but at underlined support also, right? So this is another study by which we can develop. Okay, so these are all the things we have done today. This induced topology has further generalization, further studies and all in topological algebraic structures. Right? So these are the references I have for your understanding and for further research. Okay. So we have also done something related to that. Okay. So the really fuzzy soft space and all we only tried, and those separation axioms and all we have done. Okay. Of course, Zade, he is the founder rather for the study of fuzzy sets and all. Right? So this Wang only developed the fuzzy points and the fuzzy Longinus and all. Okay. So I stop here. Okay. So with this, I come to the slide of this particular important one. Okay. Thank you all. Right. Thanks for the patient listening and all. Okay. If you have any queries, you can make now. Okay. This is the time for your queries. Yeah, you ask any questions, please.
Sir?
Yeah, please.
Sir, Dr. Suresh.
Yes. Please, sir.
Complex number applicable for fuzzy as a member function?
So complex numbers also, okay, you can take a view as a set, and there you can talk about the fuzzy subsets and based on which all the studies and all. Right? It is only a set, you know. Right? Wherever set is there and all, we can talk about fuzzy subsets and fuzzy topology and all. Therefore, it is possible. If the question is it possible, then it is possible, right? How it is, then you have to go through that particular research. Right? So you have to collect the collection of complex domain, right? Then you think over the different fuzzy topological space, right? So in R also you have, you know, the same way. The set of real numbers you take it, then you can think over the topology and fuzzy topology on set of reals. The same way in complex domain also it is possible. Right? In my view, it is only a set, so that is possible. Is there any other further question, please?
Yes, sir. Another question from Malati Selvam. Fuzzy set with fixed point. Kindly explain about it, sir.
Yeah, it is again. It is not by one sentence we cannot explain. Okay, so fuzzy fixed point theory is a big domain where many people are doing research. Right. So the study is also available, right? So fixed point theory is also available. So for this, okay, they started with the metric space and all, right? So fuzzy metric, what is the meaning? Right? So different versions of fuzzy metrics are there. Okay, so that is another type of research. It is again, of course, mathematics is like that only. Each one is one version, right? So there and all you have to work it out. Right? Fuzzy fixed point theory is also there. So Maradai sir, Veeramani sir and all, they are working on it. Okay, so they started working very long back. Okay, they have developed a lot of things. Okay, many fixed point theorems have been generalized in terms of fuzzy. Also, they have done it. Please, any more questions, please?
Sir, a question from Sudhakar.
Yeah.
Can we use chemical structure in topological space?
Yeah, it is possible, you know, again. Right? Chemical structure means we think over it is only nothing but a node, right? A point, right? Then wherever the points are there, the points are nothing but the elements, right? Then it is a set theory, right? So based on the structure, if you want, you can give the Gradal value, right? Therefore, the Gradal value and the points are there, then automatically it's a fuzzy sets, right? Therefore, using that fuzzy sets, you can think over the topology and all. Right? It's all possible. So wherever the set theory and the Gödel values are possible, there and all you can study the fuzzy topology and fuzzy theory and all. It is possible.
Sir, a question from Divya Anand. What is the use of
Yes,
fuzzy
please.
process in the fuzzy topology?
Okay, right. So this is the question. Okay, usually we expect from any pure mathematical talk. Okay, so in the topological study, right? So we have many applications in the image processing and all. Right? So images are taken with the pixels. Right? The pixels are taken as the nodes or points, and the intensities are taken as Gödel value. Right? Therefore, the fuzzy points are there. So whenever we have fuzzy points, from the fuzzy point you can think over the induced topology and topology. Right? From the induced topology, now you can think over the translation invariance and all. Right? So once you have translation invariantness, then obviously, okay, image which is corrupted at one domain may be transformed from the other domain if you are able to develop the translation invariant metric on the particular image. Okay, so that type of study is possible. Then all you may be knowing, right? So the continuity based on which, okay, the homeomorphism and homotopy, right? By which, okay, so now you may be seeing, right? So many the teacup is nothing but the donut, that type of things, and all people they used to do that. So that and all, it is again the study is possible, right? But in teacups to donut, usually they use apply the ordinary topology, right? But here in the homotopy, of course, the fuzzy homotopy, that the intensity is also important, right? The Gödel value is also important. Therefore, the donut may be having different color, right, from the usual cup. Okay, that is the important thing. In the ordinary topology, right? So the intensity is not a matter, but now it is the intensity is also a matter because that only makes Gödel value. Therefore, so from the fuzzy homotopy and all, you can convert the teacup to the donut with the intensity levels are higher or lower. Right? Therefore, that type of study is also possible. So what are the applications available in topology? That and all, it is possible to study in fuzzy topology also, but very limited studies are done. Right? So even I have seen a paper in which, okay, the boundary is used for the identification of the cracks of the bones in the medical field. Right? Of course, boundary is nothing but our study, you know, right? The exact definition of boundary of topology only it is taken, right? But in the images they have applied, by which they have identified the cracks of bones. That means using the image processing and all. Right? Therefore, it is possible. Right? Fuzzy topology they have taken, fuzzy boundary they have taken, based on which they have invented whether the bone is getting cracked or not. Okay, you see how they have applied it. Right? So it is all possible.
Use of declassification process in topology.
The next one question, sir.
Yeah, please. Yeah, okay. So another question, okay, I have seen, right?
That can be used in fuzzy topological space. Where we use it, sir?
Which one? Which one? Please, ma'am, repeat. Pardon, madam.
Yes, sir. Alpha cut can be used in fuzzy topological spaces.
Yeah.
Where we use it?
It is possible again, right? So because Loyan, he developed one induced topology, you know, right? So from the fuzzy topological space, how he has come to induced topology, it is nothing but alpha cuts, right? So mu inverse of alpha comma 1, that way only he has started, you know. Right? So that is one study, right? So from the fuzzy topological space, if I want the topology on the universal set, then I can think over by means of alpha cuts, right? Therefore, alpha cuts for a given fuzzy topological space, they are all fuzzy sets. You just take alpha cuts for a fixed alpha, then we have collection of subsets of X, right? With respect to that collection of mu's, right? Therefore, we can check over whether it is topology on X and all. Okay, then that type of study is possible, right? But in algebra, it is very stronger version is there, right? So whenever I have fuzzy subgroup, then automatically the alpha cuts are subgroups of the universal set. Okay, that is possible. But here the alpha cuts sometimes it may be a topology by for a specific alpha. That type of things and all you can study, right? It is possible. So alpha cuts can be applied to identify the induced topology in the universe of discourse, right, from the fuzzy topology. Okay. So alpha cuts and the supports are all defuzzification. Defuzzification means what? They are all giving subsets of the universe of discourse. Right? Therefore, from the topology, fuzzy topology, I can go to topology by the alpha cuts and supports. Okay. So therefore, alpha cuts is useful. And at the same time, when you study of the topology of fuzzy numbers, then definitely it is very much useful. Right? Because fuzzy numbers are totally depending on the alpha cuts. Right? I can talk about the topology of real numbers. Therefore, topology of fuzzy numbers is also possible. Therefore, of course, it's already done. It's not a new. The topology of fuzzy real numbers already they have started and they have done it. There and all alpha cuts have more role. Right? It is that. Is there any further questions, please?
No, sir.
No, sir. Thank you, sir.
Okay. Then
Now
shall
it's the time to
I
deliver vote
stop
of
and
thanks. I invite
now,
our department colleague, Mrs. D. Jyoti, to deliver the vote of thanks.
A very good afternoon to everyone present here. On behalf of Rajapalayam Rajus College Department of Mathematics SF, deem it a great honor and privilege to deliver vote of thanks. But first of all, I would like to thank to our management and principal for providing us an opportunity to organize this session. I wish to express my gratitude to our resource person, Dr. Lakshmana Gomati Nayakam sir, to give you wonderful information about fuzzy topological space. Thank you, sir. We
thank you,
thank
madam.
you with us, sir. I
Thank
heartily
you.
congratulate to all participation for their active participation in the webinar session. Last but not least, I extend my thanks to our department staff members and also technical team for their support. Thank you guys for making this session successfully with your contribution. Thank you.
Okay, thank you all. So thanks for your nice patience and listening and all, right? So if you have any further queries and discussion, right? So you can catch me at any time in my mail ID, right? So this mail ID, it is visible to you, I hope, right? So Velu Lakshmanan at naWT.edu, right? So at any time you can catch me at this mail ID for the academic discussion on fuzzy topology, fuzzy clustering technique, and decision modeling, that type of things. Okay. I am also interested to work with you people. Okay. So thank you all.
Thank you, sir.
Thank you. Madam. Shall I stop, madam? Shall I wind up now? Shall I close it? Madam, I close it now.
Yes, sir. Stop பண்ணிக்கலாம்.
Yeah, please.